are going over homework questions in section 10.2. You are quieting down so that I can focus, and so can you and your classmates. Shush. Almost. So close. Okay, some of you guys were saying that this is really hard on your brains. But can we please look at what my struggling Algebra 1B kids from the COVID year, so that would have been, what, 3 years ago, 2 years ago? What they found to be one of the easiest skills of the year. Which is ridiculous because almost any other algebra pre-calculus student is like completing the square is awful. So how did my Algebra 1B kids? Algebra is rough. They've had little success in math up to this point. How did they ace completing the square? Because I literally drew for them a what? Square. A square needs even dimensions. To have even dimensions, I need to evenly distribute or split up my polynomial. So to evenly split up 10y, what am I going to split it into?
5y.
What times what would give me y squared? What times y would give me 5y? What times y would give me 5y? What is the only possible way to complete the square? 5 times 5 is? There is no other way. Does that make sense to your brain?
Wait, what if it's like a 9?
No stress. If it's a 9, and we need to evenly cut up a 9, I'm just going to have something fractional, like 4.5 and 4.5. So I would have something like 9 over 2 and 9 over 2 and a y and a y, and 81 over 4 would complete the square. That's what the formula that you learned probably in your Algebra 1 class to go fast had you do. Take 1/2. Why? Because you're evenly distributing the y's. 1/2 of 10 is 5. I need 5y and 5y, and those 5y's will result in 5 times 5 making 25. Take half of the middle term. You're evenly distributing and squaring it. It doesn't need to be this magical, mystical formula that you don't remember. It literally is just making a square. So what's the only thing that can fill this box? But I need to keep everything balanced. So what am I doing on the other side? The same thing. And why am I even doing this? Because I am trying to write this in my form, and my form says I want y minus k quantity perfect square, right, Wilkins? And then I'm going to go ahead and have a 4p and an x minus h. So how do I do that? Well, I factor, everybody. I factor. But if you did this with the box, it's easy, because what are your factors? And what's in between? Not a negative, because there's no negatives anywhere, so it's a plus. Plus. And over here, I have 57 and 25, negative 57 and negative 25, negative 30. What? Which is super nice, because can't I pull out a negative 16 and I have x? Would you have properly factored out a negative to have a plus 2?
I like that.
And now, can I pop off in all my information? Well, hold on. Maybe not pop off quite yet, because I need to see this negative 16 as what?
4 times negative. Yeah.
It's quadruple of something. And what is it quadruple of? It's quadruple of? And I have all my pieces. Well, I would say I have all my pieces once I visualize whether this is an up, down, right, or left parabola. No. No.
Oh, wait, left. Square.
You gotta take your time and say, who is squared? It's a right, left, and I have a negative. It must be a left, which means my focus is going to need to go this way. My directrix is going to need to go that way. And the easiest thing of all of them is my vertex, because I just take the x and flip the sign, the y and flip the sign. And then I use... What was that? Question. How do we move left for the focus? How do we move left for the focus? So Brendan, tell me what you're doing though. You're changing the x or the y. You're changing the x or the y. The x because I need to move left. It's not an up, it's not a down, it's a back. Since it's a back, I'm subtracting, and what's the distance I'm subtracting? 4. Or you can say I'm adding the p, the negative 4. I'm going to end up negative 6, comma, negative 5? Is that a negative 5? Negative 5. Where's my directrix? Well, it's the other direction, everybody. What type of line is it if it's coming off of a tick mark on the x-axis? Although the x-axis is somewhere weird up here. It's going to be an x equals, because it's like a tick mark of an x extended. X equals, instead of taking away 4, instead of going left, I'm going right, so I'm adding 4, and adding 4 is going to give me a positive 2. Thank you for all the participation. Excellent job, and we are done. So my question to you is, was 15 really all that hard? Ready, set, go. Ready, set, go. Do it yourselves. Prove it to yourselves that you can do it. Arrange it yourselves. Rearrange it yourselves. Put the blanks yourselves. Fill the blanks yourselves. Andy, go ahead. Alright, checking in to see how they have done. Hopefully they went ahead and saw that the x is the squared guy, so he is the one whose square I need to complete. They moved the other guys to the other side. Moving means subtracting, adding. Adding, doing the inverse operations. Oh, my voice is dying already. I'll try to speak quieter. No, just have to be quiet to hear me. When they went to go complete the square, I am hoping they remembered it's as easy as literally making the dimensions match. And to make the dimensions match, all I have to think about is it's a 1x and a 1x, everybody, right? So all I need to complete my square is a 1 times 1 is, Natalie, this one's a 1, right? I meant to add a 1. I don't know why that looks like a minus. It meant to be a plus. When I put to one side, I put to the other side. Then I'm able to look at it and say, hey, literally, that's an x plus 1 squared. I made it. Evenly distributed. That sounds better. On the other side, I end up with negative 6y plus 24, and that is gorgeous because I can pull out a negative 6. Even if it wasn't gorgeous, I could still pull out by division, but this is going to be nice and pretty. Is this an up or a down parabola, everybody? Oh, up, down, right, or left? Down. Because I have an x that's being squared, that's normal. I have a negative, so that's going to be that way. I had a few different gentlemen be like, hey, how does the focus and directrix work? And I bet others of you have the same question. So listen up and see if this makes sense. As long as you understand the parabola is down, as long as you understand the focus, the light bulb, the microphone is always inside the satellite dish, is always inside the flashlight bulb, is always inside the parabolic microphone, then all we have to think about is what is changing. Are the y's changing or are the x's changing? What's changing? The y's are changing. The heights are changing. I need to go straight down, which means the y's are changing. Therefore, after I go ahead and quickly identify my vertex by saying, what is the x-coordinate opposite? That's negative 1. What is the y-coordinate opposite? Positive 4. Then I can go ahead and say, hey, my focus says keep the x, but the y needs to go down. How much? Oh, no, I didn't find it yet. How much do we always go to get to the focus or the directrix? We have to know our p. My p would end up equaling negative 3 over 2. Are we good? 6 over 4 reduces. I throw in that negative 3 over 2. The focus says just put it in as is, which will result in a down, which is exactly what I need. The directrix says, oh, I had the other way. And since I'm changing the y's, it's going to be a y equals 4, and then the opposite direction. And if I was to simplify, how are we doing on our mental math, everybody? Are we in pre-cal and learning how to do fractions? Because we would, some of you are doing decimals. We could think of it as 4 minus 1.5, which would be 2.5, or we could think about it as 8 halves minus 3 halves, which would be 5 halves. And we could think about it as 8 halves plus 3 halves, which would be 11 halves. Dun, 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 dun. Do you need me to do number 16? Oh, stink, it's different. That's different too. Oh, man, I thought there was another one. Oh, well, I barely did 15 because you did 15 because you were able to do 15, right? Yes. Ooh, nice. Any questions? You can ask them now. Oh, hold on, I'm 15. Any questions? I hear the 17, Johnny. Give me 1 sec. Number 16, remember somebody hopefully on their computer is getting ready to share their screen because some of these are going to be too hard for me to do. I can do 16, I can do 18. It's going to be easier if someone has it on their screen to look at the other ones. Ryan, what was your question? Was it, do I need to go back?
Yeah, I was just saying when you're finding the perfect dimensions quadratic, divide b by 2 and then square.
Always. Always. So the people that like a formulaic way of doing it, yes, you do always take the b, you always do cut it in half, and you always do square it. But as far as those that like a visual, that's literally what I'm doing when I cut it in half and then square it. Like, I like it better with the 10 because I think this one makes a little more sense but if you like the 1 better, I guess that's okay too. Okay, number 16. What was different? Why did some people freak out? Yeah, they give you a graph. I thought it was easy when they gave you a graph. Maybe not. Question. Which standard form am I using? Y squared or x squared? Because it's a right facing. That's not an up-down. That's not normal. So therefore, I'm going to have to plug in the y minus k squared equals 4p x minus h squared. Oh, why did we... Sorry. 4p x minus h. That's not a squared, or that would be like a hyperbola. Question. What do I know? What should you know? I know a point, but what's even better than the point? The point's like blah. We'll get there in a second. The vertex, I can come on up and say, ha 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 ha. So I know that y minus 0, it's not very exciting, is equal to 4p times x minus Why is it plus? Because it's minus a negative 2. Good. Oh man, what don't I have? P. Do I have a focus? No. Can I guess one? Sure, but that's probably a bad strategy. What's the other definite thing that I do know? I know an x and I know... Come on, guys. If you know an x and y, you plug it in and you solve for the variable. And then you know the p and you know the equation, right? You don't need me to do that. 2 minus 0 is going to be 2. 2 squared is 4. 4 is equal to 4p. 0 plus 2 is 2. I fully trust that you guys should be able to figure out what p is with super quick algebra. And after that super quick algebra, all you got to do is plug it in and say, woohoo, I'm done. All right, number 18. Look at the slide. I don't know the answer. You got to solve for it. But I trust you should be able to do 2 times 4 and then divide that 4 over. It's going to be a fraction. We put the fraction and then we just plug and chug to the WebAssign. Find that equation of the tangent line. The first question that was on the board, I believe it was from Sasha. If you guys wanted me to do this one, tell her thank you. Here we go. Ready, set, even though the questions is crooked. X squared is equal to 2 times y. X squared is equal, told you she would judge. X squared is equal to 2 times y.
That was not me.
Oh, who was it? Is it Sasha?
Gosh, yeah.
That was me.
Your voice just got very high, that gentleman in the back. Why are we bagging on David? Come back. Where's my vertex? Where's my vertex? Why is it 0, 0? Why should everybody be saying 0, 0? Why should people probably not be distracted on there? Is it x minus 0 and y? Oh, there's no plus, there's no minus, no plus, no minus. Okay, 0, 0, yay. What other point do they say is on the parabola? What is a tangent line? It's a pencil. Huh. Oh, no. It curves this way. Up against the line. Otherwise known as a trajectory. Otherwise known as a tangent line. Otherwise known as a line that skims and touches only one point. Not through. That's awkward. That's cutting. But skimming. Not like skipping rocks, because that's like a boing boing. That doesn't work. But skimming across. Yeah, but it can't change direction, or else it's not a tangent line. Ooh, it's like a. Ready? What am I modeling? Because where does it go? Where does it go? When they release, if they're releasing it right, it should, well, I was saying more it should fly through the trajectory, right? Where they release it, it flies, right? Okay. Anyway, coming back. Wherever they release it at an angle. That angle is what it should fly through. Okay. Question. There's other stuff acting on it, like air and friction and gravity. But coming back, the idea. Yesterday, last time, I mentioned the way to find the magical point. What magical point? The magical point that is also on the line. The magical point that is where the line hits the x-axis or the axis of symmetry, whatever that is. But in this one, it is, the y-axis. I want the magical point because to find any line, how many points do I need? 2, and I only have 1 if it's skimming. So to find the magical point in space that will allow me to actually say what the trajectory is, I need to take a...
Distance. Use the distance formula.
Distance to what? I need to take a detour to the focus. We just can't remember that word. We need to take a detour to the focus because wherever the focus is going to be the point that is equidistant from the point on the curve and the magical point that I'm trying to find. That is the focus, another application of it. So a detour to the focus, but to take a detour to the focus, what do I need to find? The focus. I already know P. I need to find the focus. To take a detour to it, I need to find it. What? What do I set equal to 4P? Oh, because that's what's in the 4P spot. Got it. 4P is equal to 2. Therefore, P is equal to 1/2. P.S. P was equal to 1/2 over here, too, because 4 divided by 8 is 1/2. You're welcome. Plug it in. You have your answer. P is equal to 1/2. Question, where is my focus? Are you adding it to the x or to the y of the 0, 0? Because it's going up. What do I do once I know the focus? To take the detour, don't I have to know the distance? So therefore I can go ahead and say D is equal to x2 minus x1. Isn't that just going to be 2 squared? y2 minus y1, isn't that going to be 1.5 or 3/2 squared? So can I go ahead and take 4 plus 9/4? 4, which is 16/4 plus 9/4. 16/4 plus 9/4 is the same thing as 25/4, which is the same thing as 5/2. Nice mental math. If that's 5/2, where's my magical point in space if it's going to be equidistant? It's down. If it's down, what am I doing to the y if it's down? If it's down, what do I do to the y? Are you still stuck at the fractions? Oh, you guys are killing me. I see you. I see you looking at the fraction. You're going to be at negative... No, not -1. -2. -2. Thanks, Paul. Bad mental math. It's -4 over 2, which is -2. It's my magical point in space, and with my magical point in space, I have my 2 points to make a line. All right, my people way back here. I get 4 plus 9/4, and I get a common denominator. 4 over 4. We're learning fractions in pre-cal. 16 over 4 plus 9 over 4 is 25 over 4. I know I'm saying this in a way that I'm like making fun of you. I'm not. It happens every single year. But I'm hoping that we're getting better at fractions.
How much harder is calculus?
It's different. I mean, they're going to be fractions in calculus. Why else am I teaching you fractions now? It's just different.
I know it's different, but it's hard.
It's fun. You memorize. The question is, do you look at those fractions and say, screw it? Or do you say, like, I'm going to actually figure it out? That'll probably tell you whether or not you'll be successful in calculus. All right, Ryan, go.
Sorry, how do you go from the 0, like, comma 5 over 2 to the 0 negative 2? Like, after you found the fraction?
Oh, because I took my focus point. And I'm going down, which is taking away distance from the y. Taking away what distance from the y? Well, the very same distance that I need to take away. Yeah, so I found the 5 halves. The 5 halves is how far I have to go down, and down is subtraction, and so 1/2 take away 5/2 is -4/2, which is -2. And all of a sudden, I have 2 points, and with those 2 points, I can make a line. I can make a line with old school algebra 1 that says, give me one of those points, which I traditionally use the point of tangency. That's what calculus would have you do. Not that you're doing geometry necessarily in calculus, but we will be putting points into line equations. Gasp, horror. We are going to then be finding slope using something totally different than what we're doing right here. But right here we're doing old school algebra, and old school algebra says y2 minus y1 all over x2 minus x1, which is the same thing as 2. Dun 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 dun. Ryan.
So in this problem, they give you the equations, so you're able to determine if it's vertical, but if they just give you the vertex and the focus, like how are you supposed to determine the vertex?
Oh, that's when you draw a picture, which is what I said last time. I said my hints for all of these are start with a picture. Because we had an example exactly like this. We had an example with the vertex and with the focus, and so we had to draw it. And when we drew it, we said, oh, this has to be going right, because the focus is always the direction of the curve. Check out those notes. They're there for a reason. So are the examples. All right. As we're going through homework questions, that was number 18, and now I said that the other ones would be hard for me to go through and talk about unless you share your screen. People on the video, sorry, I'm going to have to tap out. And we're going to see if anybody has problems that we can go over on the screen. 10.3. P.S. You can always talk to Baron if you need some extra homework help, and maybe he gets tutoring hours, and maybe so do you, especially if you're really struggling on this section. You're welcome. Let me download this as a PDF to put into your notes. And 10.3. This is where we got to yesterday. Double check your notes and make sure you have all the details. And then we're moving on. 1. Let's go. 3, 2, 1, let's go. All right, cool kids. Section 10.3. Technically, we would normally do sections 10.1 to 10.4, although I don't like the 10.4 in our book, and so usually I go to a different book that I used to teach quite a while ago, and I go to their section 12.4. I know it sounds awkward, but it lines up with where we are. I'm still debating just a little bit, because if we do another section, do you guys know how many class times we have next week? We have Monday and Wednesday, and then the minimum day is spring fling / the AP Calculus mock exam. So with 2 days left, we could do a section, have a review day, and then have spring break. We could have a review day, have a test day, and then be done. We could have a last section day, have a review day, have a web assigned test over spring break. Take home.
Yes.
Collaboration. Using your notes and your calculator. We could do a last section, skip the review day, and do a group test. We could do a last section, do a review day, have spring break, have the test the day we get back. Although that group test, I feel like you guys really should work for that. Interesting. We'll talk about it. I think probably the 2 top options in my head right now are a web assigned test over spring break and or a group test Wednesday. But I feel like you should do something to earn that. I don't know. We'll think about it. We'll think about it. If only there was some sort of like mission drive going on right now where I can't technically give you bonus, but I could give you incentives and maybe something like that. I mean, it's over tomorrow. But if you guys bring them in tomorrow. Okay, I'm thinking. Incentivizing sounds better. Alright, here we go, 10.3. We'll figure out that answer at the end of class. 10.3. We'll see if you guys are going to earn your ideal option. My ideal option would probably be just giving you a paper pencil test. But we'll see. You have on your, I said the end of class. Stop. Here we go. You guys have x minus h over squared over a squared plus y minus k squared over b squared. This is really just a distortion, to some degree, of a normal circle equation. Remember circle equation? We could divide the r squared and we divide the r squared. They both have r squared. If they both have r squared, it's what we call a circle because in either direction you have your radius of r. Actually, I shouldn't say either direction. I should say all directions. But looking at an ellipse, we can say either. Because you go out in r, and you go up in r, and you go back in r, and you go down in r, and then it's like, oh hey, I kind of have a circle, right? But that's for a circle. What's different as soon as I say they don't have to be the same number? Well, I stop calling it r number 1, and number 2, I start using two letters, a and b, and number 3, I say now we can have an oval, otherwise known as an ellipse. Ellipse. Major. Look at the board. What does the word major go along with? Bigger. Does that make sense? Is that something we could study? Something we can remember? Something we memorize? I think so. Minor means what? Oh my goodness, you guys are geniuses. If I want to know what these radii are, don't I need to take the square root of what's in the bottom to find these radii? Are we tracking? They track a lacking, but I think it's more the lacking than tracking. Come back. How do I get the a? I square root the a squared. How do I get the b? I square root the b squared. I need to look at my denominator and take a square root. Are we tracking? Okay. So what if we keep going and we say there's one more important thing we need to talk about? That one more important thing has to do with the foci. That one more important thing has to do with the foci. Why is it not focus? Because there is not one. There are two. If there was one focus, guess what? It would be a circle because the two would be on top of each other. If it was one focus, it would actually be called the center and there would be no focus. But as soon as we start having foci separate away from the center, then we start having our circle be distorted. As soon as the two foci that are overlapping start being pulled apart, that's when we start getting our oval. So the farther apart the foci are from the center, the more elliptical the ellipse. Can I say that? I don't know. It seems a little circular, but did you get that? That was funny. I thought it was funny. We're not going to call it P. We're going to call it C. We're not going to call it P. We're going to call it C. Why? Just go with it. We have an A. We have a B. So let's go with the third letter, B and C. That C is not a point on the ellipse. That C is a distance from the center to the focus. But we're going to have two foci, so we're going to have a plus or minus. This will give me foci at H plus or minus C, K. Why am I adding to the X for the first one where the major axis is horizontal? Did you just say the number 3? That's awkward. Coming back. Why am I adding or subtracting C to the X for a horizontal major axis? Yeah. And the foci are right and left, right? So if it's right and left, I need to adjust my X value. So what do you think is going to happen when I come over here and are getting foci that are up and down from the center? Add or subtract from the K. Good. Even though equations change, strategies don't. Even though letters change, strategies don't. Things like complete the square will still be in this section. It's okay, I can take the groans. I understand them and I sympathize with them. c squared is equal to a squared minus b squared is how I can find it every single time. C squared is equal to a squared minus b squared. It's not Pythagorean theorem, it's not a squared plus b squared. Similar, but nope. Similar, but no. Although something a little bit interesting is, what if I were to rearrange this? I mean, if I were to rearrange this, technically I could say that b squared plus c squared is equal to a squared. And what does that mean? If b squared plus c squared is equal to a squared, don't I have a right triangle? But the right triangle would be taking this c, taking this b, and then taking this a. So I would have the c, I would have the b, and guess what? I would have the a. That could totally be a thing, but it's not, like, clear in the picture, so we're not going to really worry about that. There is a right triangle, but it's really weird and not obvious, and you would be breaking apart the pieces of the poor ellipse, and we're not going to do that. So, what if we were to be given a picture, like you were given last section that you freaked out on homework with a parabola, but this time it is an ellipse. Ready? The really nice thing of this section is all the standard forms are exactly the same. You're like, no, they're not. We wrote down 2. Wait. The only difference is where the bigger number goes. The only difference is where the bigger number goes. And it doesn't really matter if you can look at the picture and know the difference between horizontal and vertical. Because then I can say, oh hey, my horizontal radius is 2, so I put it under the x guy because horizontal, I mean, that's like an x thing. And then my vertical, oh hey, I'm going to put that underneath the y because, I mean, that's a vertical thing. And then, well, what do I put in my h and k spot, guys? Kind of. It's not called a vertex anymore. It's called a center, which is at the origin, but the center. The center, 0, 0. So what's my final answer? Let's see if you guys got it. Ready? It's going to be x squared over 4 times 4/9 y squared equals 1. Otherwise known as 9x squared plus 16y squared equals 36. And I know that math just got really intense for you, so give me a sec. I know that math got really intense. But why? Don't worry, I'm getting my green pen. My green pen can fill in the in-between. Take a breath. My green pen can fill in the in-between. What in-between? The in-between where you would have had an x squared over what? Plus, okay, y squared over what? When I divide by a fraction, I multiply by a light bulb. But wait a minute. Fill in the lines. I have my green pen. I'll keep filling in the lines. What the heck happened between this and that? I'm just showing you an or. I'm just showing you they're both good. What happened? GCF. What's the GCF between 4 and 9? 36. What's 36 over 4? 9. What's 36 over 9? What's 4 times 4? And then what's 36 times 1? Dun 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 dun. Right even. Well, careful. I'm deciding, but I'm deciding in an informed way. I'm deciding in a way where I know that the distance from the center to the outer edge is what we call the horizontal radius. The distance from the center to the top edge is what we call the vertical radius, as long as this isn't like rotated or shifted. And I know how my formula works. So I'm not just choosing anything. I'm deducing what these values are based on having an informed perspective of how the formulas work. Does that make sense? And so we have over here an example where technically I would be calling this A because it's the bigger one, so A is equal to 2, and then the B is the smaller one, B is equal to 3/2. If this was bigger, it'd be A equals, and that would be B equals. But really it's just like, hey, the horizontal always goes with X, the vertical always goes with Y, and we're talking about the radii, the distances. No, hold on. The bigger one is always just named A. Like, it's really nothing snazzy. So I don't make a big deal. Like, technically our book is like, A is the bigger one. You're like, yay. But what I really care about is, the horizontal goes with X and the vertical goes with Y. The horizontal goes with X and the vertical goes with Y. As long as you can match up the numbers, you're good. The letters are just like an added plus. Yeah. It can appear either way. Questions? Did the green help? Connect the dots. Show the in-between. Horizontal always goes under the X, vertical always goes under the Y. A is always the bigger one. So it's basically like, who wins? Oh, you win. We're going to give you an A. That's all it is. A and B in our formula denote distance. So as such, we're thinking how much, not where. So yes, always positive. Good question. Always positive. Just thinking of how far. Direction would be a positive or a negative, but just thinking of how far. So what if things get interesting? And they don't give us the to the edge, but instead they give us the foci. Take a second, write down your clues. I don't want to go too fast on this one because it gets interesting. And last time, the interesting examples we ignored and we got stuck on homework. So take a second, write down what you know. You know the foci. You know the major axis length. And the picture gives you the center. That's just cheating. All right. The picture gives you the center. You didn't have to know that at all. Careful. A might be easy to guess, but you can tell that B is not easy to guess. Right? Are you allowed? Sure. Are you going to get it wrong? Probably. Purple squiggly lines? You mean the pink dotted lines?
Oh, squiggly. Oops, I got my lines mixed up. Sorry.
It's okay. Made my day. All right. So, we were doing that colorblind testing a while ago. Maybe that's what's going on. In the back of the, like behind all this, guys, we have a few different things. First of all, we have this guy that we want to plug into, right? But we also have this whole relationship between C and A and B. So, sorry, I'm tapping on Miss Reyes' class. Question, what's something I do know? Anything I do know? Yeah. P.S., did you hear me say just a second ago they did not have to give that to you and the picture just happened to give it away because I gave you a picture? How would you have been able to find that if it wasn't there? Midpoint, good. Between 0 and 4, what's the distance? 4. Half of that would be 2. So then the point would be at 2. 1. Exactly. All right. Good. Go team. So we could go ahead and plug in that 2 and that 1. It's like, yay, we're making our equation, right? Who's A? Who's B? I really don't care. A is going to be the X guy because it looks longer, but whatever. I just want the numbers. But I don't have them. Brendan, I know, he's like, I think I see it at 5, and I think I could actually figure that out. But then we look at the vertical one that's like 3.0. So what do we know? Not A, not B, but we do know C. What is C? Oh. Wait, that's the formula, but what's C equal? 2, because 2 to 4, 0 to 2, the distance is 2. So I know 2 squared is equal to A squared minus B squared. Stink. We need one more clue. What's the one more clue in the wording of the question that we have not used yet? If the major axis length, careful, wording, the length, the full length is 6, what does that mean about the radii.
Divided by 3.
So you might have seen it on the picture, but you better double check it with the actual facts. Yes, the A is going to be 3 because of this clue. So I know that this is going to be, wait, why am I putting the 3 in this spot?
Oh, wait. You know the distance between the 3 points, so then you just add the rest.
Because I can go ahead and plug in 3 squared, right? So I can go ahead and say that 4 is equal to a squared minus 9. So therefore, a is equal to the square root of, any mental mathers? 13.
That's not my math.
What's my final equation going to be? X minus 2 squared all over 9 plus y minus 1 squared all over 13. Wait, how'd I get 13? Because the square root squared. Nice, Kayla, the square root squared. Oh, from back here. C squared is equal to a squared minus b squared. So 2, distance, squared is equal to a squared minus b squared. Oh, I plugged it in the wrong place. We should sue. Question. A is supposed to be the bigger guy. And who did I say was the bigger guy? Who's the bigger guy? A, and A is 3. All right. I make mistakes too. So a squared is equal to 3 squared. There he is. Minus b squared. So then I have plus and minus. Okay, so b is equal to square root of 5. Is that better? Yeah. Because I looked at the distance between the center and the focus. I think you were answering that one just a second ago. From 2 to 4 and from 0 to 2. My A is 3. My C is 2. My B, I don't know, some awkward decimal. All right, go find it. I plugged, sadly, it into the wrong space. Does it matter that we know which one's the larger, which one's the smaller? Yes. Which is why this major clue, aka the longer one, was kind of important. Then I added the b squared and I subtracted the 4. I subtracted the 9 and I divided by a negative 1. Either way, I get b is equal to square root of 5. What's the square root of 5 squared? Can anybody do mental math to get rid of the fractions in the next step as just another way of writing it? Can anybody get rid of the fractions? 45 is what we're getting. What's going to happen when we multiply everything by 45? 5. Does this make you feel a little bit like partial fractions? It should. Either one's good. Just keep an eye on the watch-its and the websites to see what they want. This is what we would call standard form. This is what we would call like clue form, because you can see all your clues. This is what we call not so cluish form. If I wanted to be really mean, I could go ahead and then do some other nasty stuff like x squared minus 4x plus 4 and 9 times y squared minus 2y plus 1 equals 45. And then I could do some other nasty stuff like 5x squared minus 20x. There's going to be a plus 20. I'll get back to that in a second. Plus 9y squared minus 18y. There's going to be a plus 9. I'll get back to that in a second. That's 29. I could go to the other side, which would end up being 29 and 45, 16. Do you think we might need to complete the square sum if they give us something like that? We might need to complete the square twice. Ryan, what was your question, kiddo? Look, there it is. Write it down and get ready. C is the distance between the center and focus. It says its distance is absolute value, so it's
Oh, that's a long one.
because we get to complete the square how many times? How many times complete the square? Because we need 1 for the x guy and 1 for the y guy. Are any of you guys less scared of this than you were before? Don't answer that question. I'm just going to pretend it's a yes. Okay, so question. We're trying to have even dimensions. We're splitting that negative 54x to be
27.
Nice, but a negative 27 and a negative 27, right?
It's negative 54 though.
A negative 27 plus a negative 27 is a negative 54.
Sorry. Yeah.
It's okay, it's okay, it's okay.
This is not a good day.
Does anybody notice something funny, though, about 9 and 54 and 27? Is there something called a G, C, F? Uh-oh. Guess what doesn't work with GCF so well? The boxes don't work so well with GCFs. And actually neither would the math, because the first step of completing the square is pull out any GCFs. So before I can even do my completing the square, I need to think about, oh, it's going to be like this. Pause and wonder, look, see if that makes sense as I get my boxes ready. Does it make sense why I have 9 and 4 over there? Because it's not just a blank, it's a 9 times blank. It's not just a blank, it's a 4 times blank, right? Keeping it balanced. What I do to one side, I have to do to the other side. So let's split up that negative 6x. What's going to be the even dimensions? So then check it. I have an x and a negative 3 and a negative 3. What's the only thing that can complete the square? 9. Perfect. Perfect. How about the other dude? Split up the 10 evenly. I'm going to have just because I'm showing you the boxes doesn't mean you have to do it every time. The question is, will it make sense in your head? And I think it will if you just give it a chance. How's it going? Take your time.
You get the 9, like when you like the 9 and the 4 when you factored them out, the GCF, you had to do it to the other side.
Because this 9 isn't just a 9, it's a 9, right? I have to think about what it really is. But now I can do things like 9 times x minus 3 squared plus 4 times y plus 5 squared. If you've done the boxes, you know what those are because they're just right there. They're the dimensions. Over here I have negative 37 plus 81 plus 100. 181 minus 37 is 150. 144. Feel free to double check my math. I would appreciate that. But if we're trying to actually find all the stuff, then we need to divide so that we can get it in our nice pretty clue form. Our nice pretty clue form says I'm equal to 1. Yes, if it's ever equal to 0, it's what we call a degenerate. If it's not equal to 1, if it's equal to 0, it's hidden lines masquerading as an ellipse. That's interesting. We'll see if you find any of those in homework. But before we go pulling out our clues, we have some reducing to do because 9 goes into 54 16 times and 4 goes into 54 30. Check it 6 times. But then all of a sudden I can do things like, hey, you know what? I know my center. My center is going to be at positive 3, negative 5. I don't need to make it all gorgeous on the graph, whatever. 3, negative 5 is where my center is going to be. My x direction, I'm going to be going out 4 in the x direction. My y direction, I'm going to be going up 6. You guys agree?
Wait, where'd you get the 6 from?
The square root of 36, the square root of 16. Remember, we have to think the square roots to find our radii, like we wrote down in our notes. It's a squared and b squared. But then all of a sudden I can go through and start identifying all my stuff. My stuff, like my center is going to be at, that looks like C as in the little c, as in the foci C, I mean center. My center is going to be at positive 3, negative 5. My foci actually, first my vertices. My vertices are going to be here and here, which is up 6 and down 6. I'm adding to the y's because that's how up and down works. My foci are going to be, I don't know, I have to go find them. C squared is equal to A squared, which is 36 minus B squared, which is 16. So my C is going to equal square root of 20, which is going to be 4 goes into 25 times 4 has a square root, 5 does not. Ugh. Well, whoever these guys are, I guess I can write them as 3, negative 5, plus or minus 2 root 5, because I don't really want to figure out what those are. The vertices are the ones that are on the edges of the major radius. So I go from my center and I go up the 6 to get to the edge, negative 5 plus 6. Or I go down 6 to get to the other edge, negative 5 minus 6. Which is how I get those vertices. My foci say take the center and move the C value, which it's gross, so I'm just writing it as a plus or minus. And then my eccentricity, that sounds ridiculously hard. Unless it's just talking about how elliptical things are, and how elliptical things are can just be found by a nice little simple ratio of, well, how far away are your foci from your edge radius, or what's the ratio of the foci to the edge radius, which would be 2 rad 5 all over 6. Or rad 5 all over 3. P.S. That is the one formula that we have not taken or written down today. So that's the last formula you guys need to get for ellipses. This guy, eccentricity, the ratio. How far the foci are away from what the major radius is. If the foci are 0, then it's a circle, and 0 over A means there is no eccentricity, there is no squishedness, there is no ellipticalness. I know I'm making up words now. E is eccentricity. The ratio of C over A, and don't worry, I got you, it's right there. It's how oval something is. If C is really small, the eccentricity is really small. If C is really big, the eccentricity is really big, and it's all something between 0 and 1. Eccentricity of 0 says, I'm a circle, because I don't have foci. They're overlapping. And 1 says, oh my goodness, I'm a straight line. Completely flattened circle. I'll go back to the other page in 1 second, but this is the last formula you need to get down. Never mind, I'm making up things. Okay. Oh, that's it. It's okay, my algebra kids don't even know my name or the first letter of my name, so that's awkward.
Really?
Well, one special one.
I mean, I believe that.
One special one. He was like, Miss, I don't know. Like,
Boomer. Yeah, it's gotta be Boomer.
it's March. That's fine.
There's a person named Mark.
Oh no.
You guys are so
Chill out.
It's because their brains are working so hard on math. Got you. Did you get your last formula? Oh my goodness, how many slides are, we're done, all right. Go team. I'm going back to the last example. A few of you guys were still writing it down. We are done with ellipses and we are done with 10.3 and we have 4 minutes to figure out whether or not simplifying your options for taking a chapter 10 test is worth anything to you. If you promise to bring cans tomorrow, I'll make an assignment out of it. All you gotta do is submit a picture and be like, look, I'm supporting this school. And then I'll say, well, I'll incentivize that. I'll give you an option. Well, or today.
Everyone bring hands.
Do you want a choice or do you not want a choice? That's the question.
Do you know the tax rate for California?
The tax rate?
Yes.
Off the top of my head?
Well,
No, I just pay that tax.
That's probably more. When you buy a large thing,
If it's food, it shouldn't be taxed.
it's just
There's tax on Chipotle. I always get taxed.
like if I buy gas,
Sometimes it's
it costs $500 without tax to buy like.
I $5.
You basically buy one can. No, but like if you want to win for the like 5-day weekend, for the 5-day redraft, we can turn in 1,000 cans for $500 of canned beans or sweet peas or like at 3.5 cents an hour.
Every person in the grade.
Okay, do you guys want a choice or no?
Yes.
Alright, so we're doing the canned food thing for tomorrow?
Yes. We are.
Alright, so then now careful, I need at least the majority of you to bring in food and then put a Google Classroom assignment up, and all it says is submit a picture of you donating food. Could you lose your integrity and lie? How sad, you're not donating and you're lying. But anyway, I need the majority of you guys to turn in canned food, and then I say, alright, I will honor your choice. Your choice right now is between a WebAssign, online, collaborative, well I guess if you choose to collaborate, otherwise you get lots of time and resources. WebAssign over break, or with a review day, or no review day and you work together on it next Wednesday. So either working together on it the day that you're here and you get it done before spring break and it's a paper pencil, or it's WebAssign and it's over break. Better get it done, and if you don't get it done, it's a 0. Ready? Set? I'm going to say WebAssign first. I'm going to say pencil, paper together before, after. WebAssign first, paper, pencil together before break, and have it out of your life. Who says WebAssign? I'll take the initiative. I'll get it done. WebAssign? I need to count. This is going to be close. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's not close anymore. All right, WebAssign wins. Which means we get another section and we get a review day and you do WebAssign over break and you have it done the day we get back, which is a Tuesday and an A day. All right, guys, get out of here. Bye.